We are going to talk about the Doppler effect. And the Doppler effect is the apparent change of frequency due to the relative motion between the source and the observer. This sentence has a lot of things to analyze. For instance, in order to have a Doppler effect, there should be a source and the observer. The source generates a sound, and the observer is going to listen to the sound. The source is generating a sound with certain frequency, but the observer will perceive another frequency. It's an apparent change. The frequency is not changing per se, but the observer is going to listen to other frequency. Why? Because there is a motion relative between both of them. It is very important to understand we're talking about frequency. You have heard the Doppler effect from previous situations like an ambulance or a siren. It happens to every wave. So the frequency that is going to be perceived by the observer is going to be equal to the frequency that is going to be generated by the source times a ratio of velocities. The velocity of sound plus minus the velocity of the observer over the velocity of sound minus plus the velocity of the source. When do we generate a plus or a minus in each case? If the observer is moving towards the source, is going to be positive. If the observer is moving away of the source, it's going to be negative. So once again, positive if the observer is moving towards the source, negative if it's moving away of the source. In the same situation, if the source is moving towards the observer, then it's going to be negative, but if it's moving away from the observer, it's going to be positive. The frequency observed is changing. Be very careful to understand this is the frequency and not the sound level. The sound level will be decreasing due to another very useful situation about 20 logarithm of the ratios. If this is moving away from the source very, very far away, that's the reason why the decibels are going to be going downwards. In this case, we're talking about frequencies.